Hello, I'm going to do a quick demonstration of the balancing function in SKF's new handheld analyzer, the Microlog dBX. I've got a few images of the Microlog up here on the left, as well as a remote desktop to the actual physical device, which we're going to look at rather than trying to focus the camera on the screen of the device, so it'll be very clear. We start off in the balancing module, and you can see there's a lot of possibilities with it. I'm going to do, you can do up to 4 planes. For this small rotor kit that I have behind me, it's a single plane balancing, and so we'll stick with a single plane. I'm going to go ahead and use, I do have 4 accelerometers plugged into the 4 channels of the Microlog dBX, so I'm going to go ahead and utilize that, and then I can look at the tolerance. So this will be shown as we get into the correction weight additions later on. I'm going to stick with a G2.5 to the ISO 1940 standard, and then that is again going to affect, it'll digitally show on the graph how close I am to having balanced to that G2.5. If I return back and continue to the next step, we can see the locations, position 1 and 3 in the vertical, 2 and 4 in the horizontal, and then I have a setting where I can look at I can customize the sensitivities and the display units that I want to use, whatever I'm comfortable with. I'm choosing millimeters per second to keep it fairly universal, and I'll hit next. Then it begins to collect data. It's got the speed here, and I'll go ahead and say OK, and it'll begin capturing the vibration. The nice thing about having the 4 sensors is that I can kind of look across the entire, across both bearings and see how the phase is. For this particular installation, the table is not very rigid, so the phases are mostly in phase with each other, just because even though it is a very, it's a situation that balance will fix, because the table is fairly flexible, the phases show up in the same. So I'm going to go ahead and hit next to get to the next screen. Now I can choose whether I want to add or remove the, add or cut the weight, the trial weight that I put in. And then after I've done that, whether I want to remove or have that trial weight remain. Then one other thing I can do is I can estimate the trial weight using the numbers that I've programmed in for this particular installation. And so I'm going to use a bolt, small bolt that I have for balancing. I'm going to put it at 0 degrees just because that's simplest. There is a function within the dBX that allows you to set it to the exact, based on the coast down, it can determine what the optimal place to put that weight is. But I'm going to keep it simple, put it at 0. And I'm going to take a quick break here and pause the video while I mount that. Alright, I went in and added the trial weight and collected the trial weight vibration, and you can see that in all cases the data point with the circle around it is the latest reading, and in all cases the vibration increased dramatically. So the trial weight was much larger than it had to be. So we'll go ahead and hit, but we've got that data point. Now we'll hit next to get to the next screen, and we can see that here's our original vibration. The white line represents the ISO 1940 grade that we selected, and it tells me that I want to add 1.12 grams at 199 degrees. My particular rotor kit has threaded holes, so I'm going to go to Tools and Component. I have 16 holes around it, so it tells me exactly which, in a nice visual graph, exactly which hole and how much weight to put into each one of those. Once again, I'll take a quick break and pause the video while I add those weights. Okay, I removed the trial weight, added the correction weights, and collected another set of data. And you can see that the vibration started off in not too bad. The trial weight sent it way out, and then the correction weight brought it very nicely in. we hit next, you can see that the original run, and we've got the current run, so we're almost within that ISO 1940 range. And so we can continue to balance. So once again, I can go to the component, tells me exactly where I should put that weight in which holes, and so I can continue that process. But I think that demonstrated what I wanted to show you about the balancing module. And just one other quick note is you have lots of tools here as you go through the process to either look at your history, to go back and retake data, or to look at various methods of adding weight and changing the tolerance. So thanks for watching, and I hope you enjoy it.